Hello and welcome to this video course on transform techniques for engineers. This course is comprised of four transform techniques that we will be learning. To start with, we discuss about Fourier transform for periodic signals, and for non-periodic signals we discuss Fourier transform, and then we discuss Laplace transform, finally Z transform. In this course you will be learning the definition of these transforms and their properties, and then finally their application part. For example, many physical systems you see the data is being repeated. So, it is kind of a periodic signal or a periodic function. So, how to represent this periodic function as a discrete frequencies? At discrete frequencies you can break it, and you define it as those coefficients, you define it as a Fourier transform for a periodic signal, and then you, for the inverse transform, you get back this as a Fourier series, that is your actual signal or the function. Okay? And then for non-periodic signals you can define what is a Fourier transform and its inverse transform through Fourier integral theorem. So, that is similar to the Fourier series. Given signal, how we represent as a Fourier series, that involves the Fourier transform or the Fourier coefficients. So, this is what we discuss and on Fourier transforms and its properties, and many of Fourier transform versions, for example cosine transform and sine transform, and their properties, and then their applications in ordinary differential equations, partial differential equations, and then also other applications of them. For example, you can solve some integral equations, you can evaluate some integrals. Many other applications in other areas can be done. We restricted to these applications in this course. Moving on to Laplace transform, we define again same way, Laplace transform and Z transform. We define naturally how we define it, this definitions of this transform and its inverse transform, and then its properties and their applications. This is what you will be learning in this course. So, prerequisites of this course, a minimum what the student is required to know is a little bit of calculus, complex variables technique, for example integration technique in the complex variables, and then some differential equations, just to understand what kind of problems we solve. What do you mean by problem? So, differential equation problem, if you understand, that is enough. So if you understand a physical problem, how you represent mathematically as a differential equation with initial and boundary conditions, and then we can use these techniques, these transform techniques to solve these kind of problems as an application. So, minimum what we require is calculus, complex variable techniques, and differential equations. Okay? So, I wish you all the best. Thank you very much.